imagine sliding a vintage, I don't know, $50,000 luxury watch across a jeweler's velvet display pad.
Right, a really high-end piece.
Exactly. And the weight of it, it feels absolutely perfect in your hand. The ticking is like virtually silent. It's completely flawless. And you have this human expert, someone with maybe 20 years of experience, right?
Yeah, master appraiser.
Right. And they put a loop to their eye, and they
Yeah.
examine the dial, they check the hands, the sweeping motion of the second hand, and they do this for like 20 agonizing minutes.
Because that's what it takes.
Exactly. And finally, they declare it authentic. But then you take your phone out. You snap a single, well-lit photograph of that exact same watch.
Just a standard smartphone picture.
Yeah, just a picture. You upload it to an application, and in less than 2 seconds, an algorithm flags it as a counterfeit.
It creates this immediate, really profound friction.
Oh, totally.
Because we are so used to trusting the human eye, right? The accumulated intuition of a craftsman.
Yeah, that gut feeling they have.
Exactly. But when a machine looks at that same physical object, it isn't seeing the romance of the watch. It is seeing a cold, hard, mathematical terrain.
It's just pixels and math.
Right. And increasingly, the machine is spotting things that the human eye simply cannot perceive.
Well, welcome to the deep dive. If you're listening to this right now and you're wondering how on earth an app can outsmart a human expert on a piece of $50,000 hardware, you are in exactly the right place.
We have an absolutely incredible stack of sources you've provided us today.
We really do. We are looking at a recent press release from a technology company called Hoken Tech. And even more importantly, we have our hands on a highly detailed, multi-page AI diagnostic report.
Generated by their flagship system.
Right, which is called TrustWatch. And just for context, this report is dated July 6th, 2026.
Which is great because it places us at the absolute bleeding edge of machine learning and computer vision.
It's fresh.
It's very fresh. And for anyone trying to understand the intersection of artificial intelligence and physical commerce, I mean, this document is a gold mine.
Oh, absolutely.
We are moving completely out of the realm of theory here and right into the realm of high-stakes, real-world application.
So our mission today is to take you right under the hood of this cutting-edge technology. We aren't just going to look at a fake luxury watch, though. Spoiler alert, we do have a fascinating fake to dissect today.
We sure do.
The real goal is to unpack exactly how artificial intelligence is evolving to essentially see and, more importantly, explain authenticity in a world where high-end counterfeits are getting, honestly, terrifyingly good.
Yeah, the super fakes.
We really want to understand the mechanics of this system.
And a crucial concept to keep in mind as we analyze this material, for everyone listening, is this massive philosophical shift in artificial intelligence.
Okay, unpack that a bit.
Well, for a long time, AI operated as this unexplainable oracle. It was what developers call a black box. You fed data in, and it spat a verdict out. Real or fake. Yes or no.
But you never knew how it got there.
Exactly. You never truly knew why it made that specific decision. But what Hoken Tech is attempting with TrustWatch is to totally shatter that black box.
They want to break it open.
Right. They are building a system that is transparent, it's operational, and it's capable of actually showing its work to a human being.
I love that framing. Showing its work. Like a math test.
Exactly like a math test.
So let's get right into the actual patient on the operating table today. Let's pull up the specific watch that was fed into the TrustWatch system and generated this July 2026 report.
Okay, so we're looking at a document tagged with request ID 883DB61A and then a long string of characters.
We don't need to read the whole thing, but yeah.
Right, but the point is, this isn't a promotional mock-up.
Oh, right.
This is the raw, unvarnished output from a single image upload into their actual production system.
Let me paint a picture for you so you can visualize exactly what the machine is analyzing. Because it's striking.
It really is a beautiful-looking object.
Yeah. So the visual evidence provided in the report, the original image uploaded by the user, it shows a very striking gold-coned Rolex. It features a black bezel around the outside edge that reads units per hour.
Which is your classic chronograph styling.
Right. And on the gold dial itself, there are 3 dark subdials. And the text right below the iconic 5-pointed crown logo reads, in very tiny print, Oyster Perpetual Superlative Chronometer, officially certified cosmograph.
That's a mouthful.
It is a mouthful. But to the untrained eye, or honestly, even to a moderately trained collector who's just scrolling quickly through photos on a luxury auction website, I mean, this looks entirely legitimate.
Oh, for sure. It carries all the visual cues.
Yeah.
The specific typography, the layout, and that aesthetic weight of prestige that you would expect from a really high-end timepiece.
Counterfeiters have absolutely mastered the macro-level illusion here.
They have. But then we look at the bold, unapologetic red text right at the very top of the TrustWatch report.
It doesn't hold back.
The automated verdict, FA key, risk level, high.
Boom.
Yeah, there is no hedging here. The system drops the hammer immediately.
It is incredibly decisive.
Yeah.
But what makes this report fascinating, at least to me, isn't just the final verdict. It's the breakdown of the AI's internal class scores.
Yes. This gives us our very first glimpse into the mind of the machine.
Right, how it actually processes probability. So the breakdown is wild. It says the AI is 79.0% confident that this watch is a fake.
Mm-hmm.
It is 17.5% confident that it is real.
Okay.
And this is the part that genuinely stopped me in my tracks. It is 3.4% confident that this object is, quote, not a watch.
That 3.4% is just a beautiful, stark reminder that we are dealing with a statistical model.
Right.
It's a mathematical construct, not a human appraiser.
Yeah.
I mean, if you handed that heavy gold medal object to a jeweler...
They'd know what it is.
Exactly. They would never, ever think, you know, there's a roughly 3 in 100 chance that I am actually holding a bicycle.
Go coffee mug.
Right.
Right.
Because a human contextualizes. We know what a watch is, fundamentally.
Precisely. We have a fundamental intrinsic understanding of the object's nature. But an AI doesn't know what a watch actually is.
It has no concept of time or wrists.
No, it only maps pixel patterns. It analyzes the specific arrangement of light, shadow, color, and geometry in that two-dimensional image.
So why does it think it might not be a watch?
Well, when it says it is 3.4% confident this is not a watch, it is just acknowledging a marginal probability that the specific arrangement of shapes and reflections in this photograph might correlate more closely with a completely different category of objects in its vast training data.
Like what?
Maybe the glare on the gold bezel resembles the rim of a brass instrument.
Oh, interesting. Or maybe the texture of the background throws off the shape recognition. It is being mathematically thorough. It leaves room for every statistical possibility, no matter how counterintuitive that seems to a human.
Okay, wow. That fundamentally changes the way you have to read these reports.
Yeah.
It really forces you to realize you are looking at a probability matrix, not a human opinion.
Exactly.
But here is where I really need to push back and unpack something.
Yeah.
Because right below those percentages is a narrative summary that kind of blew my mind.
The text block.
Yeah, the text block. The report doesn't just give us the percentages. It provides a highly articulate paragraph explaining the verdict.
It's very detailed.
It is. It states that the serial number appears to be fabricated. It notes that the watch's weight and dimensions are slightly off from the manufacturer's specifications. And it mentions that the internal movement and specific dial details do not align with the expected design language of the brand.
It reads like a comprehensive dossier compiled by a senior investigator.
It does. But wait, hang on. I'm trying to wrap my head around the physics of this.
Yeah.
We established that TrustWatch is analyzing an image.
Correct.
So how on earth does an artificial intelligence analyzing a single, flat, two-dimensional JPEG know that the physical weight and the millimeter dimensions of the object are off?
Right.
Or that the hidden internal mechanical movement inside the case is wrong? I mean, it feels like a doctor diagnosing a patient with high blood pressure just by looking at a Polaroid photograph of their face. Yeah. You cannot weigh a photograph.
That is an exceptionally sharp observation, and it points directly to how these enterprise-level systems are actually built to be used in the real world.
Okay, so what am I missing?
To understand this, we have to read the report's own framing very carefully. Right at the top, the document labels itself an AI-assisted analytical document.
Assisted. That is a very deliberate choice of words.
It is the key to the whole mystery. While the deep learning model is undeniably crunching the visual pixels of the uploaded photograph to arrive at that 79% fake probability, the broader TrustWatch system is not operating in a vacuum.
So it's not just the picture.
No, it is a holistic platform.
Mm-hmm.
When a professional authenticator or a dealer uses this system, they aren't just blindly uploading a photo and crossing their fingers. The human operator guiding the request is highly likely inputting other known physical metrics into the profile.
Ooh. Okay, so they put the watch on a literal scale, they measure it with calipers, and they type those numbers into the software alongside the photo.
Exactly. They transcribe the serial number engraved on the case. They input the physical weight. The TrustWatch system then aggregates this hard physical data with the visual AI analysis.
Pulling it all together.
Yeah, right. It cross-references the inputted serial number against known databases of fabricated numbers. It compares the inputted weight against the manufacturer's true specifications. And then it synthesizes all of this, the machine vision output and the database lookups, to generate this cohesive, readable narrative summary.
That makes so much more sense. It's essentially acting as a central diagnostic hub. It takes the human's physical measurements and the AI's visual analysis and just fuses them together.
Which illustrates Hoken Tech's overarching strategy perfectly. I mean, in their press release, they state very clearly that their goal is to provide a complete experience.
Yeah, not just a gimmick.
Right. They recognize that an AI simply spitting out 79% fake based on pixels isn't really enough to run a multi-million-dollar business on.
No, you'd be laughed out of the room.
The AI is the visual anchor. It's the most technologically advanced component, but it has to be integrated into a broader, highly practical diagnostic tool.
Okay, that makes complete sense. The narrative summary is brilliant for giving us the final synthesized verdict, and I understand how the physical data gets in there now. But it still leaves me with a burning question about the AI's specific role.
Go ahead.
The narrative mentions that the dial details don't align, but what does that actually mean to a computer?
The visual mechanics.
Yeah. How is it arriving at that conclusion from a picture? If we are really moving away from the black box, I need to see how the machine thinks.
And that leads us logically to what I consider the absolute standout feature of the Hoken Tech press release.
The new visual tool they've introduced.
Yes, you are referring to the heat map.
Heat map. The press release dedicates a significant amount of space to detailing this evolution of the TrustWatch platform. They explain that the primary goal of this update is to turn a simple binary result or even a percentage score into a transparent, accessible, and explainable output. So when you look at the PDF report, right next to the original photograph of the gold Rolex, we get a second image. It is the exact same photo, but it has been overlaid with these glowing, radioactive-looking orange and red spots.
And this is the exact moment where we transition from blindly trusting an oracle to actually understanding the mechanic. This is explainable AI in action.
And if you look closely at exactly where this heat map is focusing, I mean, it is mesmerizing. It isn't just dropping a massive red blob over the Rolex logo and saying, oh, the whole thing is bad.
No, it's very precise.
Extremely precise. The AI is heavily, intensely focused on very specific geographical regions of the watch face. The brightest glowing spots are clustered directly over the three small subdials. The chronograph registers.
Yes.
It is also lighting up very specific hour markers around the outer edge, and it is highlighting the spacing of the text printed on the dial.
What we need to dissect here is why this concept of explainability is considered the holy grail in modern artificial intelligence.
Because everyone wants to know how it works.
Well, yes, but for years, the single biggest criticism of neural networks was their absolute opacity. You knew what data you fed into them, and you knew the verdict they spat out. But the millions of internal mathematical calculations, the hidden layers of the network, were a complete mystery.
The black box.
Black box. If an AI made a mistake, you couldn't debug its logic because it didn't use human logic. This heat map completely shatters that box.
I was thinking about it like it's like having a teacher grade a complex calculus test.
Okay, I like that.
Traditional AI just hands you back your paper with a giant red F at the top. You failed, but you have no idea which step of the equation you messed up.
You're just left guessing.
Right. But the heat map is the teacher going through your work and circling the exact line where you forgot to carry the 1. It pinpoints the error.
That is a brilliant analogy. It highlights the specific areas of the image where the mathematical model detected critical elements or structural anomalies that drove its final percentage score.
It's literally showing its work.
It is. It guides the human user, essentially saying, look, I believe this object is a counterfeit, and my mathematical reasoning is anchored right here in the microscopic spacing of this specific subdial.
It's so cool. But I do want to push back on one specific phrase mentioned in the press release.
Sure.
Alongside the heat map, the text talks about introducing image alignment charts.
Yes.
It says these are designed to contextualize the analyzed photo against reference images from their vast data set. Now, when I read alignment charts, my mind immediately went to a police lineup,
Okay, a lineup.
or even more technically, like a facial recognition scanner at an airport security checkpoint. You know how those systems map the geometric distance between your eyes, the bridge of your nose, and your jawline, and then they try to overlay that wireframe onto a known database?
Do you know what you mean?
Is that what TrustWatch is doing? And more importantly, does handing an alignment chart to a human watch collector actually make things easier to understand? Or is it just burying them in more complex technical data?
It is a very fair question, and it really speaks to the challenge of user interface in advanced technology. But if we consider who the end user of this system is...
Right. Who's actually buying this software?
Exactly. We're talking about a professional authenticator, a pawn shop owner, or a serious high-stakes collector. And for them, this visual framework is exactly what they need. Think about how a human expert operates.
Okay.
When a master authenticator looks at a suspicious watch, they aren't just looking at it in a vacuum. They are constantly referencing a mental database built over decades. They have looked at 10,000 authentic Daytonas.
Right. They know what the real spacings should feel like instinctively. They know how the light should play off the metal of the subdial.
Exactly. They have an intuitive, internalized alignment chart.
Oh, that's a great way to put it.
What TrustWatch is doing with these digital alignment charts and heat maps is taking its own vast, perfect, mathematically precise digital memory of thousands of authentic watches and making it visual for the human.
So it's externalizing that mental database.
Yes. It allows the human operator to interpret the AI's verdict within a broader framework of visual consistency. It isn't just saying 79% fake.
Right.
It is saying, here's your watch, and here is the geometric alignment of a known authentic watch. Look at the variance in this specific quadrant. It bridges the translation gap between machine perception and human expertise.
Okay, that frames it perfectly. It's not replacing the expert's eye. It's giving the expert's eye a microscopic overlay.
Exactly.
It's like having the world's most observant, mathematically perfect assistant standing over your shoulder pointing to the exact flaw and saying, hey, compare this edge to the reference.
It takes the abstract math and it makes it tangible.
I completely see the value in that. But let's be honest for a second. A heat map is still, at its core, a visual aid.
It is.
It is pretty, it is intuitive, and it glows. But if I'm a professional dealer, and my reputation and tens of thousands of dollars are on the line, pretty pictures aren't enough.
You want the hard numbers.
I want to see the receipts. I want to see the empirical data backing up that glowing orange dot. And to truly trust this AI, we have to leave the visual realm entirely and dive into the rigorous, heavily quantitative diagnostic plots included in the second half of this PDF report.
And this transition is exactly where we separate the casual, consumer-grade novelty apps from true enterprise-grade diagnostic systems. Anyone can generate a heat map, really.
You put a filter on your phone.
Exactly. But proving statistical reliability requires deep data transparency.
So we're moving into a section of the report titled Per Upload Diagnostic Plots. There are three main charts here, and their entire purpose is to position our specific fake gold Daytona against the AI's entire historical validation behavior.
Right.
The first chart we need to unpack is called Upload Score versus Historical Real/Fake Distributions.
This chart is the bedrock of contextualizing the result. Without this, the 79% fake score is just an isolated number floating in space.
Let me describe what this looks like for you because it's a very specific type of graph. It is essentially a density graph. Think of it like a series of rolling peaks and valleys.
Mm-hmm.
On the left side of the graph, peaking very sharply, you're the 0.0 mark, which represents a 0% probability of being a real watch.
Mm-hmm.
You have a massive, dense spike colored red.
And what does that red spike represent?
That red mountain represents all the historical fake watches the system has ever tested.
Right.
Now, on the far right side of the graph, peaking near the 1.0 mark, which is 100% probability of being real, you have a massive spike-colored green.
Mm-hmm.
Those are the historical real watches.
Okay, so fakes on the left, reals on the right.
Exactly. And then there's a dotted black line dropping straight down from the top of the chart, right through the 0.150 mark on the bottom axis.
And that singular dotted line represents the specific watch we are looking at today.
Yes. This is where the statistics translate into reality. The report states the probability of real score for our watch is 0.150.
Yeah.
So in highly practical terms, what does it mean for a professional dealer to see that dotted line sitting squarely, unequivocally, deep inside that massive red spike on the left?
In practical business terms, it means the model isn't guessing and it isn't confused.
It's certain.
It is certain. It means the system is taking the visual signature of your specific watch and laying it over the signatures of thousands of known, confirmed counterfeits and known, confirmed authentic pieces.
And seeing where it fits.
Exactly. The fact that the 0.150 score lands so firmly within the densest part of the historical red peak means that your watch exhibits the exact mathematical pixel-level hallmarks of the counterfeit training dataset.
Oh, wow.
There is zero ambiguity here. Your watch isn't sitting in the flat valley in the middle of the graph exhibiting some weird mix of traits. It is, mathematically speaking, deep in enemy territory.
That firmly anchors the AI's opinion.
Sure.
It says, I'm not just telling you this is fake. I'm showing you that it mathematically groups perfectly with every other fake I've ever seen. That makes the 79% fake score feel infinitely more grounded. But speaking of how the AI groups things, we need to talk about the next chart.
Oh, boy. The ROC curves.
The current operating point on ROC and PR curves. Now, looking at this chart on the page, it is deeply intimidating.
It is dense.
It's just lines and acronyms.
The ROC curve, which stands for the receiver operating characteristic, and the precision recall curve, or PR curve, are the absolute gold standards in data science for evaluating how well a classification model actually performs.
Okay.
If you want to know if an AI is actually good or if it's just marketing fluff, you look at these curves.
Okay, let me try to translate this into a real-world scenario so we can grasp what these curves are actually measuring. The report shows the current ROC operating point as a single black dot pinned at the very, very top left corner of the graph. The axis labels tell us this represents a 1.0 true positive rate and a 0.0 false positive rate.
Which is the ideal state.
Right, so let's use an analogy. Imagine a security metal detector in an international airport.
Yeah.
The goal of the metal detector is to find weapons, right?
Okay.
So those are our fakes. If a metal detector is tuned so perfectly that it catches every single weapon that walks through it, never missing a single one, that would be a 1.0 true positive rate. It successfully flags every positive instance.
Okay, follow you.
But the trade-off is usually that to be that sensitive, it goes off constantly for harmless things like belt buckles or keys or foil wrappers.
Right, the false alarms.
Exactly, the false positives. But this chart is showing a 0.0 false positive rate. Does that mean our hypothetical metal detector catches every single weapon, but miraculously never, ever accidentally beeps for a belt buckle? Is that the level of precision we were looking at here?
That is an exceptionally clear and accurate analogy. Yes, that is exactly what the top left corner of an ROC curve represents. A perfect ROC curve hugs that top left corner as tightly as possible. It means the system is maximizing its ability to catch the actual fakes, the true positives, without accidentally classifying a genuine, authentic watch as a fake.
Which is huge.
And in the luxury watch market, that distinction is absolutely critical.
Because the stakes of a false positive are catastrophic.
Oh, completely.
I mean, nobody wants their genuine $50,000 family heirloom branded as a cheap counterfeit by a machine. It would destroy a dealer's reputation instantly.
Exactly. The cost of a false positive in this industry isn't just a minor annoyance. It is a loss of immense financial value and, more importantly, trust.
Yeah, you lose the client forever.
And the PR curve, the precision recall curve sitting right next to it on the page, validates your metal detector analogy even further.
How so? What does the PR curve tell us that the ROC curve doesn't? I mean, they seem kind of similar.
They are related, but they measure slightly different things. Recall is basically your true positive rate. Out of all the total fakes out there in the real world, how many did you successfully find?
Okay.
Precision asks a different question. It asks, when the alarm actually rings, when the system shouts fake, how often is it correct?
I see.
The PR chart in this report shows a perfectly flat line hovering at 1.0 precision across almost the entire recall axis, right until the very, very end.
So it never dips.
It rarely dips. This indicates that when TrustWatch raises an alarm, the reliability of that specific alarm is remarkably tight. The historical trade-off between catching every single fake and accidentally making a mistake is almost non-existent at this specific operating threshold.
If it beeps, you can trust the beep.
Exactly. If it beeps, you can trust the beep.
It is intensely confident, and based on these historical curves, it is right. But I have to play devil's advocate here.
Please do.
Those specific plots, the density graph, the dot on the ROC curve, they just show the historical context for our single upload, this one gold Daytona. They show where this watch fits. But if I really want to know If I can trust this entire software platform with my multi-million-dollar business inventory, I need to know how well the underlying mathematical model performed across its entire rigorous testing phase before it ever even saw my watch.
You want to see the whole exam?
I need to see the exam scores.
Well, we need to zoom out from the individual patient and look at the clinical trial data.
Exactly. And that logically leads us to the final analytical section of the PDF, the model evaluation plots located at the bottom of the report. This is the ultimate test of the system's architecture. And it starts with something called the confusion matrix.
Yes, the confusion matrix is where AI developers have to go to face reality.
It sounds ominous.
It is where marketing claims go to die. It strips away all the fancy percentages, the glowing heat maps, and the smoothed out curves, and it just gives you the raw, unyielding hard counts of right and wrong on a held-out test dataset.
Okay, let's break down the exact numbers in this matrix because they are staggering. The grid shows us exactly how the model categorized roughly 600 test images. We have 294 true fakes, meaning the watch was a known counterfeit and the AI accurately predicted it as fake.
Good.
We have 275 true reals, meaning the watch was genuinely authentic and the AI accurately predicted it as real.
Also good.
And it even had a tiny category where it correctly identified 4 not watch images, keeping that bizarre edge case category completely accurate.
What you are looking for in a healthy confusion matrix is which perfectly contextualizes why the overall ROC curve graph, summarizing the entire model, shows an area under the curve, or AUC, of 0.9999.
Okay, for someone who hasn't taken a statistics class recently like me, how good is 0.999?
Let's scale it. An AUC of 1.0 represents mathematical perfection.
Okay.
It's a flawless system that never makes a single mistake. An AUC of 0.5 represents a literal coin toss. The AI is just guessing randomly.
50-50.
Right. To achieve an AUC of 0.9999 and an average precision on the PR curve, also at 0.9999, is phenomenal.
It's almost unheard of.
It is as close to flawless as you will realistically ever see in a live production environment, dealing with the messy, high-fidelity variations of physical objects photographed in varying lighting conditions. It means the model is exceptionally robust.
Which is incredibly impressive on a technical level.
Yeah.
But I am looking at the prediction scatter chart. Notes to the matrix. This chart visualizes all of those hundreds of test results simultaneously. It plots every single watch tested as an individual dot, creating this beautiful, sweeping S-curve.
Right, the sigmoid shape.
Yeah. You have all the orange dots representing the true fakes clustering tightly in a flat horizontal line at the very bottom near the 0 probability mark. And you have the blue dots, the true reals, clustering tightly at the very top near the 1.0 probability mark.
And that S-curve visually demonstrates that the model is highly decisive. It doesn't hover in the middle, agonizing over a guess. It firmly pushes objects to the extremes of known real or known fake.
Yes, it is highly decisive for 99% of the dots. But right in the middle of that S-curve, right in the vertical jump between the bottom floor and the top ceiling, there are 3 distinct red circles.
Yes.
The report explicitly labels them misclassified. These are those 3 mistakes from the confusion matrix we just talked about. These are the borderline cases where the probability sat right in that muddy, dangerous middle zone between a score of 0.3 and 0.6.
If we connect those 3 red circles to the bigger picture and specifically look at the final 2 charts on that page, the calibration curve and the confidence distribution, we actually gain a lot of insight.
How so?
The calibration curve shows that the model's stated confidence generally matches reality perfectly. When it says it is 90% sure, it is right 90% of the time.
Okay.
The confidence distribution chart shows huge, sharp peaks near 0 and 1, visually proving that the AI is rarely undecided. But, as you rightly point out, those red circles exist.
They are right there on the page.
That muddy middle zone of uncertainty is real. The system is not infallible.
So here's my ultimate pushback on this entire system. Let's put ourselves in the shoes of a buyer.
Okay, let's do it.
You are standing in a shop and you are about to spend $50,000 on a vintage Daytona, even with a miraculous AUC of 0.99999. We just proved that there are misclassifications.
Yes.
Based on this test set, it's roughly a 1 in 300 error rate. If you are that buyer or the dealer brokering the sale, how do you handle that tiny but very real, very expensive margin of error? How do you sleep at night knowing your $50,000 watch might be that one red circle in the middle of the graph?
You handle it by understanding the fundamental limitations of the tool, which Hoken Tech actually acknowledges in the very last section of their report. If you scroll all the way to the bottom, you find the disclaimer.
Ah, the fine print always holds the truth.
Exactly. The document explicitly legally states, quote, "It is supportive material only and does not replace qualified human review."
Wow.
This single sentence is the crux of modern applied artificial intelligence. TrustWatch is not designed to be the final judge, jury, and executioner of authenticity. It is not designed to eliminate the human expert.
So what is its role if it isn't the final say? Why pay for it?
It is a profoundly powerful high-speed filter. It is an augmentation tool. Think about the workload of a major auction house. They might have 1,000 watches pass through their doors in a single week.
Right, the volume is insane.
They cannot spend 20 minutes examining every single one with a loupe. It's impossible. The AI clears away the noise. It accurately categorizes the 99% of obvious fakes and obvious reals instantly with 99.99% accuracy.
Okay, I see where you're going.
This allows the human expert to conserve their mental energy, their time, and their highly specialized skills to focus exclusively on that tiny, muddy margin of borderline cases, those 3 red circles.
Oh, that reframes the entire technology for me.
Yeah.
It's not replacing the human appraiser. It's giving the human appraiser a superpower.
Exactly.
It handles the volume so the human can handle the nuance.
Precisely. It is a symbiotic relationship between human intuition and machine scalability.
And that profound need for human review, that crucial interaction between the human expert and the machine-generated data, is exactly why Hoken Tech fundamentally redesigned how this information is packaged and delivered. Which brings us to the final evolution of this technology we need to discuss. Moving from pure computer code to actual commerce.
Yes, we are transitioning from discussing the technical output of a neural network to discussing its value as a true business asset.
Going back to the Hoken Tech press release, they make a surprisingly huge deal out of the introduction of PDF report generation.
They do.
Now, to an outsider, or someone who follows Silicon Valley trends, generating a PDF sounds like a feature from, what, 1998?
Yeah, it's not very sexy.
No, it does not sound like bleeding-edge artificial intelligence.
Yeah.
But the press release frames this as a massive, revolutionary leap forward for their platform. They highlight the business rationale heavily, the need for internal archiving, the ability to share results with clients, collaborators, and business partners.
Because they understand that in the luxury market, trust is built on standardization and paper trails.
Right. They also emphasize the enhanced textual report, which is that narrative summary we spent so much time discussing at the very beginning. They explicitly state it is designed to guide the user with descriptive info and useful indications for decision-making. So let's pull all of this together. If we trace the journey of this technology based on these sources, we have gone from a binary computer script, likely hidden on a remote server somewhere, spitting out a raw 1 or a 0 to an API,
Right.
to this highly professional, structurally sound, visually rich, and instantly shareable dossier.
And what this evolution signifies is that Hoken Tech understands a fundamental truth about enterprise technology. A purely mathematical result, no matter how accurate, is largely useless in the real world if it cannot be communicated effectively to the people who need to make financial decisions based upon it.
Because if they don't understand it,
Yeah.
they won't use it.
Exactly. By generating a comprehensive PDF, they are combining the speed of the algorithm with clarity and interpretive support. This upgrade isn't just about tweaking internal math to get from 0.9998 to 0.999 accuracy.
It's beyond the math.
It is about making AI, as they specifically say in the text, oriented toward real-world use. My core belief has always been that data is meaningless. Knowledge is only valuable when it is understood and applied. A confusing, raw AI output creates friction. It makes users doubt the system.
Right, they get suspicious.
But a beautifully structured PDF report, complete with heat maps, historical context curves, and a narrative summary, creates a solid foundation for a business transaction.
Looking at this entire ecosystem, from your perspective, you, the listener, who is constantly trying to learn, adapt, and catch up on where these complex fields are heading, I think the real aha moment of this deep dive isn't just that the algorithms are getting smarter at spotting microscopic flaws in a subdial.
No, it's bigger than that.
The real paradigm-shifting innovation is that the AI is getting vastly better at communicating with humans.
It is learning our language.
Exactly. It is learning to use our language.
Sure.
It is using visual metaphors like heat maps. It is writing professional narrative summaries. And it is organizing data into digestible charts to build trust.
It is actively bridging the translation gap between the opaque precision of a machine and the necessary intuition of a human being. It is making the complex completely accessible.
It really is an incredible leap forward. Just to quickly summarize the massive journey we've been on today. We started by looking at a single uploaded photograph of a fake gold Rolex.
Just one picture.
We watched as the TrustWatch AI not only flagged it as a high risk, but used a visual heat map to literally highlight the microscopic flaws in the chronograph registers. We waded deep into the statistical matrices, translating ROC curves and density plots to mathematically prove the AI's overwhelming reliability against hundreds of test cases. And finally, we saw how all of that raw blinding data was refined and packaged into a polished, professional PDF report that empowers a human being to make a confident, multi-thousand-dollar decision.
It is a textbook example of applied technological evolution. It is literally how science fiction becomes everyday commerce.
But as always, before we wrap up, I want to leave you with a final, slightly provocative thought to mull over.
Okay, lay it on us.
We have spent the last hour talking extensively about how incredibly good the artificial intelligence is getting. But let's look at the other side of the equation. As diagnostic systems like TrustWatch get closer and closer to absolute perfection, boasting an AUC of 0.9999, and as they learn to mathematically map and analyze every single pixel of authenticity, wait, I shouldn't say that, as they map every pixel, how will the counterfeiters respond?
It is an inevitable, unbreakable cycle of escalation.
Think about the implications of the heat map. If the AI can highlight on a glowing, color-coded map exactly what makes a watch fake, the specific spacing of the dial text, the exact millimeter alignment of a subdial, aren't we essentially handing the counterfeiters the exact blueprint of what they need to fix to beat the machine the next time around?
You are absolutely right. The tool designed to catch them becomes an evolutionary pressure on the black market itself. They will use the AI to QA their own fakes.
Quality assurance for criminals.
Exactly.
The AI forces the fakes to get better, which in turn forces the AI developers to make the system sharper, looking for even more microscopic anomalies. We are watching the dawn of a high-tech arms race.
That's exactly what it is.
It is ancient, meticulous, illegal craftsmanship going head-to-head with bleeding-edge artificial intelligence. And looking at these reports, I think that race is only just beginning.
It raises a vital philosophical question about the future of physical authenticity itself. If a fake is mathematically indistinguishable from the real thing, what does real even mean anymore?
Wow, that is a question that will keep a lot of collectors awake at night. Thank you so much for providing such rich, multi-layered sources today. It is a fantastic reminder that staying truly well-informed means you can't just read the headline or look at the final percentage score.
You have to dig deeper.
You have to look closely at the data underneath. You have to be willing to wade into the diagnostic muddy waters. And sometimes you just have to hope your X-ray machine is calibrated correctly. We will see you next time on The Deep Dive.